Okay, hey everyone. All right, so we're going to be going over today's homework, and this is dealing with fractions, but you are using pattern blocks. And I know I did not get pattern blocks to you ahead of time, so you're going to follow along, and hopefully this can help. Or you also had this one with you. Remember this sheet right here? So you could use that as a guide for you. All right, so look at the first one. It says that Michelle brought 3 candy bars with her to lunch. So she has a total of 3 candy bars. Now she ate, so Michelle ate 1/2 of one. So I'm going to put Michelle ate 1/2. Her friends ate 1 1/3. So these are going to be friends. And this is going to be, let me move this half up just a little bit more. Oh, no, not on the camera. Yeah, the camera, it's not showing. Okay, so then we have her friends ate 1 1/3 of candy. So I have 1 1/3. Remember, there's a total of 3 bars. So every time I see that, I think of the Hershey's uh, chocolate bars or the Hershey's almond bars, and then you can break those up into pieces. All right, let's take a look at this first one. If Michelle ate half, so remember that we used a hexagon for half. If she ate half, how much is not eaten? Very good. Half is not eaten. So I'm going to put left is 1/2. If her friends ate 1 whole and this is 1/3, remember, it takes how many of the rhombuses to make a whole? So I'm going to actually just use this right here. So they only ate 1/3 of it. So they ate 1, so I'm going to get rid of that, and 1/3. This rhombus is going to represent that. So how many is not eaten? Very good. 2/3 is not eaten, right? Because it takes 3 rhombuses to make a whole. So they only ate 1 of it, so I have 2 that have not been eaten. So I have 1/2 that's not been eaten, and I have 2/3 that have not been eaten. So I'm going to get rid of that part. So here I have the question is how much is left over? All right. Now, let's go ahead and think about which shape can we use that can go into the trapezoid and the rhombus. All right, remember we've been doing this in class. So with my trapezoid, I can use how many shapes? How many triangles? Absolutely. I can use 3 of those. Remember that it takes 6 of those to make a whole. I'm going to go get my sheet. Okay, so remember here, it takes 6 triangles to make a whole. Well, I'm only using 3 of those, so it's going to be 3 out of the 6. Let me see if I can see it that way. I'm only using 3 out of the 6. So my one trapezoid, which is equivalent to 1/2. So I'm going to create my equation. I have 1/2, and I'm going to combine these because I want to find out how much is left over. So I have 1/2 plus 2/3. I said that my 1/2 can be converted to 3 of the 6, or 3 out of 6, or 3/6. So listen to the language and what makes you help you remember it more. I can say 3/6. I heard kids to say 3 of 6, and I heard kids saying 3 out of 6. If that's what's helping your brain remember, then please utilize that, okay? So 1/2 is equal to 3/6. Here I have my 2/3. This is 1/3, 2/3. And I'm going to use, I know that if I split this in half, it's going to take 2 triangles for each rhombus. So combined, how many triangles do I have for my rhombuses or my rhombi? I get my other triangle here. All right. So how many do I have? 1, 2, 3, 4. So 2/3 is equal to 4 out of the 6. Okay. So now can I add these together? Absolutely. I can come through here and count them. I have 3, 4, 5, 6, 7. So I have a total of 7 out of the 6, 7, 6. Remember that if you're going to just be adding those up, I'm going to place this up here, move this down just a bit. My denominators stay the same when I'm adding or subtracting only. The denominators need to be the same and they never change. So I carry that over there. I'm only going to be adding my numerators because the value, the number that makes that whole never changes. But how many I'm using, no, they do. I almost said does, but that's not right. So 3 plus 4 equals 7. Now, remember in 3rd and 4th grade, we call this an improper fraction when my numerator is greater than my denominator. So we have talked about this numerous times. This is called the dividing bar or fraction bar. This means that 6 goes into 7 one time, and then I'm counting up because 7 minus 6 equals 1. So I count up. I can always go 6, 7, it's 1. That becomes my numerator then, and then my denominator stays the same. So this is what it would look like pictorial wise. Here is my whole. Well, actually, here is my 1/2, right? And so I have that there. And I'm going to add 3 more. This is 1, 2, 3. So now I have 1 whole, and what's left over? 1/6. So I can remove these because I found the equivalent fraction. So now I have 1, there's a total of 7, 6, or 7 of the 6, which means that I'm going to have a mixed number. It's an improper fraction. So I have 1 whole here with 1/6 left over. And so how much of the candy is left over? 1 bar and 1/6 of that other bar is left over. Okay, now let's move over to the next question. How much more did Michelle's friends eat than she did? Okay, so now we're looking at Michelle. She ate 1/2. So I'm going to put M for Michelle, 1/2. And I'm going to put friends, and they ate 1 1/3. Okay, so now I need to find out how much more did they eat than Michelle? What operation am I going to use to find it? Yes, we're going to be subtracting. So I'm going to write subtract. Now I have 1 1/3 minus 1/2. So here is my 1. We're using pictures. Using my hexagon as 1 whole. Remember, a rhombus is going to be represented for 1/3, and I'm going to subtract out 1/2. And that was my trapezoid. So I'm subtracting those out. But before I can do that, I have to find equivalent denominators. They have to be the same. So what shape can we use that will go into my trapezoid, that will also go into my rhombus, that will also go into my hexagon? Absolutely, the triangle, right? So I can have 2 triangles here for my rhombi, so that makes it 1, 2 of the 6. How many do I need for my trapezoid? Absolutely, I have 3. So that makes it a value of 3, 6. And how many for my hexagon? Yep, you got it right. It's going to take 6 of these guys here, 6 triangles. Coming over to my bag, that will equal to 1 whole. All right, so my equation then, this is that 1 1/3. So here, my 1 1/3, this is going to be 6 over 6, plus the 1/3 is equal to 2 of the 6. And then I need to subtract out 1, 2, 3 of the 6. Okay, so what is 6 plus 2? My denominator stays the same because my value is 6's, the 6. That's right, so it's 8. Am I representing 8 here? That's 6, 7, 8. So I do have that 8. Now I'm needing to take 3 because I'm just representing this one here, so I'm going to take that away. I need to take 3 6 out of the 8 6 here. So I'm going to take away these 2 here and 1 more. What am I left with? Very good. I'm left with 5 6. So the friends ate 5 6 more candy than Michelle. And another way of thinking of it is like, how close are they eating 1 whole bar more than Michelle? Yeah, all they had to do was eat that 1/6 part, and they would have had the other bar, right? So yeah, they were close to eating both bars. So very good. All right, let's move over to the next one. Michelle is buying fruit at the grocery store. All right, go to the grocery store. Most of the time, you're buying some fruit. You go to the fruit section. She buys 2 1/3 pounds of apples. And so I'm going to put apples here. That's 2 1/3. And 1 1/2 of cherries. 1 1/2. I'm so sorry. 1/2 pound of cherries. How much fruit has Michelle bought at the store? So what operation when we want to find out the total amount? Very good. We're going to be adding. I'm going to add my apples and I'm going to add my cherries together. So here is just going to be 1/2 pound. So here's my equation. You had the 2 1/3 plus 1/2. Okay, again, I'm going to get my 2 wholes. I'm going to get my rhombus because that represents my 1/3. And then I'm going to add 1/2 to it. All right, my holes are going to stay together, so I'm going to add those in just a moment. What shape pattern block am I going to use that will go into the rhombus that will also go into the trapezoid? You're right, it's going to be the triangle. So here I'm going to have the 1/3 is equal to how many 6's? Very good, it's 2. 1 6, 2 6. So here I'm bringing this down. I'm going to circle my whole numbers because I'm going to add my whole numbers separately. So my 1/3 is equal to 2 6. How many triangles for my trapezoid? Very good. So that's 3. Catching on. So reason why we're doing it with the pattern blocks, because then we're going to move away from the pattern blocks using the array, and I want you to be able to see it quicker and clearer. But you missed a lot of the fractions last year, so it's really important that we go back to those basics. So 1/2 is equivalent to 1 2 3 6. Now can I add? Yes, I have the same denominator. I'm going to circle my denominators when I'm adding and subtracting to remind me that that's all going to stay the same. All right, draw that arrow. They all stay the same. Okay, and now I'm going to go to the top. How many 6's do I have here in my picture? 1, 2, 3, 4, 5. Is 2 plus 3 equal 5? Yes, it is. So it's going to be 5, 6. I'm going to bring my 2 plus 2 wholes is going to equal 2 and 5, 6. So here they bought 2 and 5, 6 pounds. So again, let's see, Michelle bought 2 and 5, 6 pounds of fruit. How far was she away from buying the 3 pounds? Yeah, she was only 1/6 away. Here's 1 pound. Here's 2 pounds. That's how much she bought, right? So she's only 1/6 away from having a total of 3 pounds. So I think that she just probably added another apple. And it could have been, or maybe just slightly over, depending on the size. If it's those little small red apples, she could have had the 3 pounds. Or maybe just a little bit of, maybe a couple of cherries. All right, let's look at the next question. So far, are you doing okay? If not, leave me a message or come in and see me in the morning. How much more apples did she buy than cherries? Okay, well, I know apples is 2 and 1/3. I'm going to put A, 2 and 1/3. What operation will I need to find the difference when I'm comparing how much more? Is much more, how much more means subtraction. So you're absolutely right. I'm going to subtract that out. And then I'm going to put C for cherries and 1/2. I've already, see, I did the addition over here. I've already figured out that I have the 2 and 2/6 minus 3/6. Now, I will show you when we get into the subtracting out mixed numbers how to borrow, but right now we are doing using pattern blocks. So I have the 2 and 2/6, right? And all of these here. So if I went through and put my 6 on here, I have 6, 6. How many totals 1/6 do I have? How many total triangles do I have? So this is 6. And if I continued on and this is 6, what is 6 plus 6? That's right, it's 12. Plus 2 more? Very good, it's 14. So now I can change this over to 14 over 6. So this would be 14 over 6. So 2 and 1/3 is the same as 2 and 2/6, which is also the same as 14 over 6 minus, so if I had 14 over 6, do I even have enough for 6 more? I don't know. I'm checking to see if I have enough. I do not. I thought I did. Okay, so I'm going to take out 3 triangles. So I'm going to remove this one. 1, 2, 3. Now remember that this is 6 here. I have 6 triangles, right? How many triangles do I have left? So if this is 6, 7, 8, 9, 10, 11, is 14 minus 3 11? Yep, it is. So that's 11 over 6. So this is 1 whole. What is my fraction then? 1 and what? 1, 2, 3, 4, 5. Very good. So 11 over 6, which is an improper fraction. To change my improper fraction into a mixed number, 6 goes into 11 one time, with how many left over? So 6, 7, 8, 9, 10, 11. I just count it so that you can see. 5 is my remainder. That goes on top for my numerator. My denominator never changes, stays the same. So it's 1 and 5/6. So she bought 1 and 5/6 pounds. So I'm going to just put Michelle bought 1 pound and 5/6, 1 and 5/6 pounds more apples than cherries. Okay, and that's what that one is. So it's this process. I want to see, make sure that you are understanding when you are uh, finding your equivalent fractions and your common denominator. And then we'll show you again how to change this up when we get to that point in the next couple of days. But right now it is just using your pattern blocks. All right, the next one. Sam has 5/6 of a bag of marbles. Jonathan has 1/2 of a bag more than Sam, but 1/2 of a bag less than Carrie. So how many bags of marbles does Carrie have? So you're like, ay, 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 my brain. Yes, absolutely. But write it down because it'll be easier. Okay, this is what Sam has. He's got 5/6 of a bag. Does he have a full bag? No, he does not. He's missing 1/6 to get a full bag of marbles, right? So with Jonathan, Jonathan has 1/2 of a bag more than Sam. So I'm going to put J. One half more than Sam. Oops. But 1/6 less than Carrie. So this goes back to Jonathan has 1/6 less than Carrie. All right, now watch what we do. First, I'm going to deal with Sam and Jonathan because I need to find out what Jonathan has. What are we going to do? Because if Jonathan has 1/2 of a bag more than Sam, and Sam is 5/6, I'm going to put S up here. What operation will I use? Yeah, we're going to add those together. So 5/6 plus 1/2. Again, I'm going to have my 5/6. So I already have this one. I did have it ready. So it's 1, 2, 1, 6, 2, 6, 3, 6, 4, 6, 5, 6. Ah, come on. Wish I had the Velcro kind or the sticky kind. All right, that works out. And this is 1/2, which represents my trapezoid, right? How many how many 1/6 will go on here? How many triangles? Yeah, remember 3 triangles? So I have 1, 2, 3. What's the value of 3 triangles? Very good. 3, 6. So if I'm going to add all of these up, I'm going to draw my arrow down so I know that 1/2, my 5/6 is going to stay the same. My 1/2 is equivalent to 1, 2, 3, 6. So can I add those up now? Yep. So 5, 6, 7, 8. So I have 8 of the 6. But look at this, improper fraction. If I move one of these over here, so now he has a bag that has what? 1 and 1/6, 2/6. 6 goes into 8 one time with how many left over? 6, 7, 8 with 2 left over, and my denominator stays the same. So Jonathan is 1 and 2/6. I'm not going to switch that over because here, looking at the bottom, it says how many bags of marbles do 3 children have altogether? Well, I want to keep the same denominator because I'm adding those up. So here, this is going to be Jonathan. I'm going to put J for Jonathan. Now, Jonathan has 1/6. So here it says 1 and 2/6, but 1/6 of a bag less than Carrie. So to find out what Carrie has, so think about this. I have 1 and 2/6. That's mine. I have 1, and remember I can split this in half. So if the 2 and 6, remember that it's going to be 1, 2, 6. So it's 1 and 1/3 because that's same as a rhombus, right? So it's 1 and 1/3 or 1 and 2/6. They're equivalent. So this is mine. And say Miss Davis. So I have 1/6 less than Miss Davis. Who has more, me or Miss Davis? Yeah, Miss Davis would have more because she has more, 1/6 more than I do. So I have less than that 1/6. So what am I going to do here? To find out for Miss Davis, and here we have Carrie, I'm going to have the 1 and 2/6 plus. So I need you to make sure that you're drawing this out or you put different names in there so you can look at it. So if I throw in one more 6, how much does Carrie? So this is Jonathan. This is 1/6. Carrie has this, he has 1 less than but more than Carrie, and I need to find out for Carrie. So Carrie has 1 and 3/6. That's Carrie's. Now I can easily simplify this, but again, over here, I'm going to need to add all those up, right? So I'm going to keep my denominators the same because it says how many bags of marbles do 3 children have altogether? Okay, well, Sam is 5/6, so I'm going to put Sam here, plus Jonathan, this was Jonathan, 1 and 2/6, and this is Carrie, 1 and 3/6. So I'm going to put J and then K. Who has the most here? Yeah, look at Carrie. He has 1 and 1, 2, 3, 6 more. So this is what it will be. So this is the same as 1 and 1/2. So he has the most. Who has the second most? Absolutely right. It's going to be Jonathan. And who has the least amount? Poor little Sam. So how much do they have all together? I'm circling my whole numbers because I need to add those separately. So I'm going to represent that this is one whole and this is one whole. So if I have 5, 6, 7, 8, 9, 10, 6, because remember I have to add 5 more and I don't have enough. So this is 5, 6, 7, 8, 9, 10. And I have 1 plus 1 equals 2. This is going to be 2 plus 10, 6. How many groups of 6 can go into 10? Very good, only 1. So I'm going to put my 2 plus, this is going to be 1. How many are left over? 4, 6. So what is 2 plus 1? And I'm going to circle my whole numbers so I remember that those get added separately. So this will be 3 and 4, 6. So look at this. If I needed to simplify, 3 and 4, 6. They're both even numbers, right? That means that I have 4 of the 6. So I'm going to go ahead and take, this means 1, 2, 3 wholes, and 4, 6. What shape do you have? 1, 2, 3, 4. Yeah, these are rhombuses, and a rhombus represents 1/3. So you're going to have 4, 3, and 1/3, 2/3. Okay, so I have 1 rhombus and 2 rhombus. If that's confusing you, I'm just going to put this one here. So that's 1/3, and that's 2/3. So I have 1, 2, 3, and 2/3. So you may see it like this, or you may see it like that. Another thing to remember, if your numerator and your denominator are even numbers, always remember, because remember we did this with prime and composites. With prime numbers, if they're, with the exception of 2, if you can split them in half, they're going to have multiples. It's going to be a prime number, so you can split 4 in half, that would be 2. Split 6 in half, that would be 3. Over here, I can't split the 3 and the 6, but I know that 3 can go into 6 one time. 3 can go into itself, and whenever it can go into the numerator, then can 3 go into 6? So yes, so this would be 1. 3 goes into 6 twice. So it's 1 and 1/2 there. Okay, so it can be either one that you see. All right, we have the last one for this evening. And you're probably saying, "Ooh, thank goodness," and you're right. Geraldine is making biscuits for breakfast. Oh, yummy. She uses 2/3 cups of flour to begin. Okay, so this is flour. So I have flour here. She has 2/3 cups. Put a C for cups. Then she adds 1.5 cups of flour when she realizes it's not enough. So then she has 1 1/2 more cups of flour and also 2/3 cups of sugar. So sugar, okay, 2 and 3 cups. And we'll get off task. So how many cups of ingredients does she have so far? What operation am I going to use? Yeah, you're going to add them all together. So let's go ahead and do this. So I have 2/3 plus 1 1 1/2 plus 2/3. I have 2/3 here. I have 1 1/2 and another 2/3. Now, parents out there that are watching, we're only doing this for visual. We would not do our fractions like this all the time. We're leading up to that on finding the common denominator using area models. But because it was such a big part in 4th grade, I'm going back to where they're able to visualize it and to make it a little bit easier. So here I have 2/3. Which ones can I add together that are the same? Yeah, look at this. I have 2 rhombi, right? Oops, what did I do wrong? Good catch. This was that, because that's only 1/3. So that's 2/3. So good job. And that's 2/3. So I have 2/3 plus 1 1/2 plus 1/3, 2/3. So here now I can add these together. And what do I get? Absolutely. So I'm going to pull these out. 2/3 plus 2/3 equals, I have a total of 1, 2, 3, 4. 4/3, which is also the same as what? Very good. 1 1/3. So I just move those around. So this is equal to 1 1/3. Now I can take this and I can add it to my 1 1/2. I'm going to circle my whole numbers because I'm going to add those together. So this is my whole number. So these whole numbers are going to stay together. My 1/3 and my 1/2. What shape can I use to show equivalent fractions? So I have the same shape to add up. Absolutely right. We're going to use the triangle. So it's going to be 2 triangles for a rhombus and 1, 2, 3. So here for my 1/3, that's equal to 1 2 of the 6 plus, don't forget my 1's up there, my 1/2 is equal to 3 of the 6. So what is that equal to? Remember, my denominators are going to stay the same. 2 plus 3 equals 5. And what is 1 plus 1 equals 2. So the ingredients as they used all together was 2 and 5, 6. So the total ingredients So do I show 2? 1, 2 holes, and 1, 2, 3, 4, 5, 6. Okay. Now, how much more flour does she use than sugar? Oh, so what are we going to need to do? Yeah, I'm going to write this down. I need to add my flour. What will I need to do next? Absolutely. Subtract that from my sugar. All right. So here I have 2/3. This is for flour, 2/3 cup plus 1 1/2 cup. I know that my 2/3, so I'm going to kind of erase my board. I have 1 2/3, right? That's my run by. And I have 1 1/2. What can I do to combine these? Yeah, see, I can just switch over to my triangles. So my 2/3 is going to be equal to what? Very good. 4, 6. Good job. So 2/3 is equivalent to 4 over 6, or 4 out of 6. If this is going to be how many triangles? Very good. I'm going to have 6 triangles. I'm just going to write 6 triangles. Not 6 A's, but 6 triangles. I'll go ahead. I hear somebody saying, just put them on there. Okay, okay, okay. Doing it so that you can visually see it. Okay, and then how many triangles here? It's going to be 3 of those. And so this is 2 and 3. Okay, so now how many triangles do I have? That's right, I have 6 for my one hole, 7, 8, 9. So this is going to be 9, 6. Now, one of the things, let me do it this way. I know that there's, for the one here, because I'm using the denominator 6, that's going to be 6 over 6 plus, I'm going to put this in parentheses, 1, 2, 3 out of the 6, and that's how I get the 9, 6. I'm going to move it over here. I have 4, 6, and that's how I got 9, 6. So I wanted to show you where that came from. So this is 9, 10, 11, 12, 13, 6. So I have a total of 13. Are we good so far? Now, how much sugar did we have? Do, 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 do. Oh, honey, honey. Okay, sidetrack. Squirrel. Okay, so now I have 13. This is flour. I needed to take 2/3 of my sugar out. What did I say my 2/3 was worth? Very good. It's 1, 2, 3, 4 of the 6. So I have 13, 6, which is my flour. I'm going to put that for flour. Minus 4 of the 6 for sugar equals, I know, I hear y'all saying, sugar, do, 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 do. I feel like baking. Okay. So now you have 9. So I'm going to take out 4. 12, that's 13. How much am I left with? 6, 7, 8, 9. I have 9, 6 that's left. What is going to be that? It's going to be one whole and how many? 1, 2, 3 of the 6. So this is equal to 6 goes into 9 one time. How many is left over? 6, 7, 8, 9, 3, 6. Okay, so also look at my 3 6 is equivalent to 1/2. So I have 1 whole and 1/2. So 3 6 is equal to 1/2. And so here they used 1.5 cups more flour than sugar. So Geraldine, I'm just going to put, no, I'll just write Geraldine because that's what I started to write. Used 1 1/2 cups more flour, more flour. You can write then sugar, I just ran out of space. All right, that's it for tonight. Guys, if you're having any questions, come see me in the morning. And we're going to do more practices. And we're moving on to another task still using the pattern blocks, but you're going to be getting more practice in. Take care. See you tomorrow. Bye.